Good afternoon. It's the last afternoon of build. Did everybody have a good week? Awesome. Learn a lot of stuff. Might have heard about a container or two, maybe some Kubernetes. I guess you're not over it yet because you're here, which is great. This build is kind of special for me for a couple reasons. It's the first time I've actually ever worn an Azure shirt on stage, because it's the first time in my 15-year career at Microsoft that I've worked on virtual machines that I'm part of the Azure team. So it's actually really exciting for me, and it's exciting for a number of us to be working even closer with a lot of our friends in Azure as we build the underlying infrastructure for Azure, and then as our team also builds a lot of the container work that you're going to see. The other reason it's kind of interesting, it's kind of special to me, is that the first big presentation I ever gave was at the predecessor to build, PDC. And it was the year that Azure was announced. And I was a much younger person, much less experienced, and I had a room of about 1,000 people watching me debug my demo live as it failed. So we're going to hope that that doesn't happen today. But this is definitely an exciting year for me. Slides are available. I always put the slides up ahead of time. Take a look through them. If this isn't the session for you, go grab 3 other people, bring them in here, and then you can go to another session. If you are going to go back and give some of this information to your team, take the slides, use the slides. If you want to build another slide deck out of it and go to a meetup, take the slides, use whatever you want out of them. Please take advantage of that. So a little bit of the journey that we've been on. So back in 2013, the Docker project got started. So that was kind of the initial commit, the first commit to what became the Docker project. Shortly thereafter, the company Docker Inc. was branded. So they moved from .cloud, where they were building this project called Docker, to being a company, Docker. In 2014, this is actually a slide from an executive slide deck that we built to greenlight our work on containers. So we sat in a conference room and said, OK, let's go ahead and build Windows containers. Now, we'd actually been working on some similar work all the way back into 2008. But at that point, we had 2 needs. We had a need from Azure. So we needed to be able to run our own services and customer services in a hostile multi-tenant, efficient, isolated way. And we were talking to customers who were saying, hey, this Docker thing's pretty cool. Can we do something similar with Windows? And so we got started on that. We made that announcement public later that year. And then as we moved into 2015, we introduced Hyper-V isolation. So Hyper-V isolation was what we had originally started talking about with our executive team on saying, OK, how do we run third-party hostile code in an isolated way efficiently with containers? And so the way that this works is we actually use a special virtual machine and we run a container inside of it. And this has become the foundation of a lot of the way our services in Azure run. At Build in 2016, we did our first demo of Windows containers. Now at the time, they took about 15 seconds to start up the first container. So we did a little dancing and we made it work. We've gotten that time down to about a second now, and we continue to work on further reducing it. Same year, we had the Docker Engine beta, and then in 2016, we made Windows Server generally available, and with the work from Docker Inc., we included, at no additional charge, the Docker Enterprise Edition engine basic with that version. 2017, we brought Linux containers to Windows, and we had 2 different releases we had Windows Server version 1709, and we announced Windows Server 2019. And then just this week, we made Windows Server version 1803 available. And so with each one of these, we've been continually making some advancements. At this point, I'm going to pause and just briefly touch on the 2 differences between the channels. So when we talk about Server 2016 and Server 2019, those are our long-term servicing channel releases, LTSC, as we call it. What does that mean to you? It means that you can get support for those for 5 plus 5 years, so 10 years of support. Right? Those come out about every 2 years. They're generally directed at customers who are running on-prem, customers who are running file servers, Active Directory, roles like that, where the upgrade cycle tends to be a little longer. We make them available with every server edition. So you can get server core, you can get server with desktop in the long-term servicing channel. And they're available to everyone. You can go buy a boxed copy of it, put it up on your mantle, whatever you do with your software. You can get it on all the clouds. You can get it everywhere. Then we have the semi-annual channel. It's my channel. That's for developers. So I get to release through the semi-annual channel every 6 months-ish, about twice a year. And what that allows us to do in the semi-annual channel is make really, really fast updates to Windows Server. So we can tweak things. We can remove drivers and features and make the container images smaller. We can optimize performance. We can fix things that weren't working previously. And we can get feedback from developers and customers and continue to make rapid progress through it. Ultimately, all of those things attribute back to the long-term servicing channel at the next time one of those becomes available. But the semi-annual channel is supported for 18 months. So what it effectively allows you to do is to skip one whole release. So you could get on version 1709, and you could ride that out until Server 2019 GAs later this fall, and then move to that if you wanted to. Or you could continue on the semi-annual channel forward. And so to kind of highlight some of this, let's look at what we've been able to do over the last 2 years in these various builds. And don't worry, this is an eye chart. We're going to blow it up. So with Server 2016, that was our initial launch of containers. I don't want to underscore that was just one line of work. There was a lot of work that went into building that. But that was the real big feature from our team was just the kind of initial support for containers. That included process and Hyper-V isolated containers. And it included a lot of the work that we did with the Docker community and with Docker Inc. on bringing the Docker Enterprise Engine into Windows Server. Right? The next release we did, version 1709. So that comes out, then the moniker is the year and then the month, give or take. So 1709 came out at Ignite last year. We did a bunch of work to optimize the container images within that. And you're going to see this as we go forward. So from 2016, our server core container image was about 5 gig to download and took 10 gigs on disk. Got a little cheat sheet over here. When we got to 1709, we got it down to 2 gig in download. So we got 3 gigs out of it. And it meant it was 4.5 gigs, almost 4.6 gigs on disk. The pull time translates from like 8 minutes down to 4 minutes and 40 seconds. So it was a huge amount of work. On Nano Server, we took Nano Server from 393 megs to download to 80 megs. So Nano Server at that point was competitive at size with a lot of the Linux distros. Right? We did that by removing things from it, making them optional layers, kind of following the containerization model. Right? We also added platform support for Linux containers. So we showed the demo a few minutes ago, the slide from DockerCon where we demoed the first Linux container. We now have the basics in the platform to run Linux containers and Windows containers side by side. We're continuing to work on that support in the open source projects, but the platform functionality is present for it. And we'll see a demo of that in a few minutes. We brought the Windows subsystem for Linux in at the same time. Why? Well, I did it so that we could say, hey, we've got Linux containers, let's run WSL so people can use Linux next to it. I also wanted it there so that for me and for other people who are more familiar with some of the Linux tools for command lines, it was easier to use server core. So now I can go to server core and I can run Nano and edit my files, or Vim if you're a Vim person, or whatever tool chain you want. I did it so we can now run SSH inside a server and connect over that, right? So it allowed us to use a lot of the same tools that we'd be familiar with on Linux on Windows directly. And then we did a bunch of work around networking, specifically things like overlays and SDN in 1709. As we look at 1803, which just became available literally this week, the container images went up yesterday, we continued to optimize that server core image. So we took it from 5 gig to 2 gig to 1.61 gig. So we got another 400 meg out of it in download size. And then on the on-disk size, we went from 4.5 gigs to 3.6 gigs. So some pretty significant savings. We got the download or the pull time down to 2 minutes and 15 seconds. So we didn't do a whole lot with Nano Server. Why? Well, we did a lot of the work in 1709 to get Nano Server smaller, and we're really looking at feedback from the community on what's still there that we could squeeze out. Did we squeeze a few more files out, or did we go too far, or do we need to bring a few things back? It's really, at this point, a community-driven or a feedback-driven initiative. My real fear with Nano is that we might have gone a little too far in a few cases. And so we need that feedback to really help guide us as we move that forward. The other thing I'll mention on server core, and we've got a note on here, we did a bunch of work on app compat. So a bunch of things that didn't work before now work. And there's a blog, it'll be in the notes for this, with a list of some of the things that we did in order to get better app compat. But a number of things that we did based on community feedback to get app compat better. All the enhancements that go into Windows 10 for WSL, now they're coming to Server 2. So background task support, all of the cool stuff that you've heard about for WSL on Windows 10 comes right in. Two things that I am really excited about, or three, I guess. We got actual real versions of curl, tar, and SSH into both server and client. So these are actually, what we did is we went and looked at the BSD license versions of them. We compiled them in the Windows build process, and we put them in box. It seems like a minor deal, but when we think about something like just writing a health check for a website, the ability to just say curl.exe, localhost, okay, I got my result. That's a great health check. Or, hey, I want to pull down a package. These things really, really are improving our workflow. Again, a bunch of networking improvements. And a lot of work we did with the Calico and open source communities on bringing in support for CNI-based plugins as part of our work for Kubernetes. So 1803 was really the first release where we really started focusing heavily on Kubernetes. Now, as we look towards Server 2019 this fall, we've continued to work on optimizing the server core image. So this is a journey for us. We're going to keep, every release, we're going to keep doing as much as we can on server core until we get to a point where we just really can't make much more. Our projection, our hope is that we're going to get it down to about 1.5 gig. That's the projection that we're aiming for. And that'll pull us down to a pull time of under 2 minutes. So still a big image. It's still a 1.5 gig image, but it's a heck of a lot better than when we started off at 5 gig. That means it's about 3 gig on disk, a heck of a lot better than 10.3 gigs that server core started at. We're going to continue to make app compat improvements. We've got a list of apps that we know continue to not work. We're going to go work on those. And if you give us more that don't work, we'll do our best to make those work as well. Some of them are going to be hard, but we're up for the challenge. We'll give them a shot. We'll keep working on them. Others, we found that, yeah, well, one line change here or there can actually make a huge difference. A huge focus is going to be on Kubernetes and Service Fabric work for us. So we're really, really trying to get Server 2019 to be the GA release for Kubernetes, so that we've got a great Kubernetes story with Server 2019 and a great Service Fabric story. So that just gives you choice in what orchestration and what platforms you use. And we'll talk about the differences between those in a little bit too. Performance and density is an ongoing area for us. And then we're going to continue to work on CNI and, of course, all the WSL stuff. And there's one more thing that we haven't announced yet that you'll have to wait for. But as we look back at this slide, one of the things I do want to make sure and kind of drive home is that we keep adding more stuff. The more you guys use stuff, the more that we hear from customers the benefits and the value of this, the easier it is for me to justify getting engineering resources on these kind of projects. And to that, we've had over 150 million Windows container images pulled now, which compared to Linux seems a little small, but we just got started. For me, this is amazing to see. In just the last 9 months, we've had over 500,000 people install the Docker Enterprise engine. And that excludes all of the cloud vendors where it's already baked into the image. So that excludes all of our Azure usage, all of our AWS usage, all of our Google, Huawei, whatever cloud you happen to choose. One of the other metrics I look at is the pull rates of our base images. So how many people are downloading a base image? You know what they say, graphs that are up and to the right are good? Well, that's a pretty great up and to the right graph. So just in April, we had 4.4 million people download a Windows container-based image, Nano Server or Server Core. Right? Now again, this excludes the clouds, where all of that's already pre-cached and loaded into it, and it excludes everybody who's using their own repositories. So if you're pulling a container image into your repo, that shows up as one pull to me. I don't get to see if it goes any further. These are just ones that are pulling it from our public image repositories, right? So we're seeing great traction with Windows containers already, and I know we're just going to see more as people continue to march forward on it. And with that, I'm actually going to bring up on stage Stephen from Docker and Anton from Jable to talk about their story kind of going through this process.
Great. Thank you so much, Taylor.
Yep.
Appreciate
There's
it.
a clicker.
Yeah, great to see that walk down memory lane between Docker and Windows Server. What a great partnership we've had over these years, and great to see Windows Server continuing to push forward and push the envelope of what's possible. So hi, everyone. My name is Stephen Follis. I'm a solutions engineer with Docker Inc. Great to be with you all today. Hope it's been a good event. And today, I want to talk a little bit about application modernization via Docker. And so first off, is from a platform perspective, I want to delineate a couple things. So when you hear Docker, you often recognize the Docker Community Edition, our free open source developer tooling. If you have Docker for Windows, Docker for Mac, it's a great on-ramp into the Docker ecosystem. But in addition to that platform, we also have the Docker Enterprise Edition platform. You saw Docker EE on a slide a moment ago. So what EE gives is a fully enterprise-capable platform ready for containers. It gives several things. First is choice. We can deploy this platform on a variety of targets. So up in public Azure, down on Azure Stack for on-prem installation, hybrid, and everywhere in between. So we have immense flexibility. Also, from a choice perspective, we ship with 2 orchestrators. So historically, we've shipped with Docker Swarm. I'm excited to say that as of last month, we now ship with Kubernetes support as well, baked directly into our platform with all the enterprise-grade capabilities right on top and usable with Kubernetes. Really exciting for us. Being an enterprise platform, security is also incredibly important. So from a governance perspective, we provide numerous tools around security and governance and the ability to take your corporate identity and extend that into your container platform. So we interface very closely with your Active Directory security groups, allow us to bring over single sign-on, and even to do role-based access control to a very granular level to ensure that the correct users and groups have the right permissions on the right containers. Additionally, our registry product goes layer by layer, scans through those images, notifies you of vulnerabilities. It helps find that needle in a haystack of that one library and that one container, helps get your arms around those types of issues. And then finally, from an agility perspective, we're able to run both Linux and Windows workloads side by side. So a single EE cluster can handle all of your Java applications, all of your .NET Framework apps, and all of your .NET Core apps all on one platform. So I call that out to differentiate what we're doing at a platform level to really operationalize container workloads. So the main kind of draws for EE is a variety of things. So including from a cloud strategies perspective, those users that are moving to the cloud, utilizing containers as that on-ramp to Azure. Being able to take that application, put in a container, and move to Azure really expedites that process. Those users that are interested in DevOps, utilizing things like Visual Studio Team Services to deploy multiple times an hour rather than once a quarter. We can utilize VSTS along with Docker containers as well to speed up that deployment process. And finally, the most exciting piece to me is being able to modernize traditional applications, or MTA as we've been calling it over the past year. This is really looking at customers that have large portfolios of applications, hundreds of applications that represent 3, 10, 15 years of development in their organizations that they're trying to figure out, what do I do with all these apps? You know, it's 2018, I want to be more efficient. There's got to be a better way than jamming everything into a VM. And that's where containers come in. So we've put together a very rigorous framework and a set of tooling that allow us to take a legacy application, place it in a container, and then deploy it on top of Enterprise Edition running in Azure, thus decoupling that application from the underlying operating system and giving immense operational benefits for those applications. We're seeing this from a variety of users all around the world and have been seeing big adoption of our platform based on that use case, right alongside all of the efforts around greenfield and microservice apps. Finally, in addition to a platform, over at Docker Inc., we're also a set of people. So we have a variety of services. So as you're walking down this cloud and container journey, right alongside you, we've got a team of support engineers, technical account managers, and all sorts of training and development folks that are there for you that help everywhere from the initial proof of concept all the way through production and beyond. So that's a bit about Docker Enterprise, what we're doing at Docker. One of the customers that we've been working very closely with along this journey is Jabil, a worldwide leader in manufacturing. And so I'm excited today to have with us on stage Mr. Anton, who's going to talk about their experiences with Docker and with Azure and what they've been able to do as far as transforming their operations with these complementary technologies. So Anton, great to have you.
Thank you. We're doing, everyone. So My name is Anton Hayward. I work on the enterprise architecture team at Jabil, and I lead the cloud adoption strategy within the enterprise. Jabil is a over 50-year-old company. It's a manufacturing services provider. We have over 100 sites in 29 different countries and over 180 dedicated employees. Jabil has a large portfolio of capabilities that cross different markets around wearables, plastics, automotive, and also healthcare, to name a few. And I like this slide just because it shows the scale of the company and the complexity that IT has to deal with that goes along with it. For a company that's been around as long as Jabil, we understand that there's always going to be change. And one of the most impactful elements of change today that we have to deal with is the behaviors on the customers. One of the behaviors is that they want instant gratification. They want instant access to information and insights. Also, they want customization in the products that we build for them. And also the rate of change that we see is accelerating itself. And as we go through this in this digital age, we put together a vision around how we're going to transform our company and move forward with a digital transformation. And we put together the digital enterprise, the digital customer, and also the digital business. The digital enterprise is where we leverage technology to enable the digital business to provide services to our customers. As you can see, the technology enablers that we leverage within the enterprise here is cloud, connectivity, information and analytics, AI and automation, and also support around our core systems. This is a typical journey that most companies will probably go through as they move into cloud, from virtualization and the physical assets in their data centers and server rooms. We leveraged our partners heavily as we made this transition from virtualization into the cloud. There's a lot of work involved with moving into the cloud, from leveraging infrastructure as a service model, where you're just moving virtual machines from one physical location to another, to also getting into leveraging the PaaS and containers. We do see in our purview that the multi-cloud aspect of adopting cloud is on our doorsteps, and most of this is because our customers are demanding that we leverage different cloud providers. So some of our customers are competitors with Microsoft. Some are competitors with AWS. So we have to be flexible in the solutions that we provide to our customers and put our applications and services in either or. And in order to do that, we leverage containers. Most people know containers are just an easy way to pack, ship, and run applications, and also get the portability to be able to deploy those applications on different infrastructures in the public cloud, also on-prem in your private cloud environments. So when we started our journey on leveraging containers, we started with just going with the open source stack. And this is what it looked like when we put it together. It was Linux operating system with a few different open source tools to be able to manage and also have the dedicated registry. Now, this is good that we had these open source solutions available to us. It allowed us to get in really quick, do some discovery, and see the pros and cons with leveraging containers within the enterprise. One thing we learned was that leveraging the full open source stack for our container environment was pretty, I guess, complex to be able to manage at scale with all the different components. And there was no real third-party support for the different solutions that we were leveraging in the open source realm. There was also no single turnkey solution that we could put in place as well at the time. So because of the complexities that we saw around trying to deploy our own container platform, we put together a team which involved our partners, Microsoft, Docker, and we set up a team that would be focused around moving forward and delivering containers as a service within the enterprise. And this was a cross-functional team that involved the infrastructure guys and also developer teams as well. And security, of course, is a very important piece of this, but we dotted lined them in. So when we got with Microsoft and Docker, they told us about this MTA program, and they hooked us up with a company called Avanade, who is the one that did the program with us. And when we assessed our landscape, we saw that we had over 200 plus developers, over 100 applications, most of which were all .NET, leveraging the .NET framework, not .NET Core. And our environment is largely built of Windows servers. During this MTA program, we picked an application that represented the large set of applications we had in our environment. As I mentioned, the .NET application, this one in particular was a 2-tier, and we required Windows authentication because of all the apps. The custom-built applications that we deployed were done on Windows and also SQL Server. A summary of the activities around the MTA program. It was a 30-day program, but all the activities that we did actually only took a week. So Avanade, the company that we worked with, they came in with these scripts, the automation to be able to deploy the POC environment, which consisted of the Docker EE platform and a few Windows servers for Active Directory and a database server. They came in and worked with the application team to take the app, bring it down to the Windows 10 desktop environment, separate the apps out from the logic, the UI, and the stuff for the database, containerize it, and then deploy it into the Docker EE POC environment. Other elements in here was that we also got out of this the CI/CD pipeline process that we will leverage with Visual Studio Team Services. We use that heavily. So being able to also see what that workflow would look like with Docker EE was very important. So the new architecture that we have in place now looks like this. As we saw in the landscape, many of our applications were .NET framework applications, not .NET Core, so we had to have Windows built into this platform, not just Linux, because what we did not want to go through is an exercise of changing all our applications from .NET framework to .NET Core. It would be a pretty lofty effort. So we were able to walk through the process of creating a process to take our applications that we have on .NET, bring them into this platform, deploy them into the platform here on the Windows 2016. The stuff we had greenfield, we would deploy in .NET Core, so we had our choice of which operating system we deployed that to, and the architecture actually got simplified from the different open source components to everything running under Docker EE, except for the pieces that we use from an infrastructure perspective in Azure around the load balancer and the storage. Also, out of the box, we got the security elements that were mentioned by Steve, the management, the runtime, the registry, the networking, and also that third-party support that we needed moving forward. So to summarize our efforts and our journey to getting into the containers as a service for our enterprise. We, again, started with the incubation team. We did our research. We kicked the tires. We found out the pros and cons within the environment. Then we engaged our partners to put together a roadmap around the platform and the infrastructure that we were going to support, leveraging Azure and Docker, and then went into the process of how we were going to leverage, do the migrations of our applications within the platform using CI/CD. We also got from the MTA program some training and knowledge transfer to help the teams develop those processes that we would use internal, and also spread the knowledge to the rest of our teams. And that's it.
All right.
Thank you.
So hopefully that was useful for you guys to hear a little bit about how an actual, real customer, real team, real company is using containers and Windows and Linux and hybrid to go through this modernization. From that point, I think it's about time we get into just a brief couple slides and then into a demo maybe? Sound good? So as we look at the local developer, this is where we start out. We're going to start out on our local machine, whether you're a developer, an IT pro, whatever you are. You need to build a container image. You need somewhere to build that container, start playing around with it, see if it's going to work. And Docker for Windows is by far, or Docker for Mac if you happen to be a Mac person, that's fine. You only heard me a little bit. Docker for Windows happens to be the best place to kind of get started with that. It's a native app. You'll see in a second. It just runs on the taskbar. And what it really does is it brings in the Docker support on the operating system. So it takes advantage of our underlying platform and brings in the Docker engine and kind of a UI and some of the tools around it. There are 2 channels for it, just like Windows has multiple channels. There's an edge channel and a stable channel. So if you like being on the bleeding edge, you like seeing the newest features, latest and greatest stuff, you can kick over to the edge channel. If you're more of a stable person, you can stay on the stable channel. Or because it's pretty easy to flip back and forth, you can go on edge, and if you encounter a problem, you can file an issue and kick back over to stable pretty easily. Similarly, we have our Windows Insider program. How many people are Windows Insiders? Yes. For those of you who aren't, please, it's the best way we get feedback. We really, really look at the feedback from the Windows Insider program heavily. Whether or not you're using it as your primary desktop, or if you want to go use our Quick Start gallery and just grab an image and run it as a Hyper-V VM, just to play around with the newest features, it really does help us understand how people are using those features, taking advantage of them, and evolving it. We also publish container images through the Windows Insider program. So we just moved to starting to publish those along with every client release. So every time a client release of Windows 10 goes out, we publish new container images, Server Core and Nano Server. And so as we're innovating on new fixes, we're working on MSMQ support, or we're trying to figure out if we can do just DTC support right now. Those are going to show up in the Insider images first. We don't get to ship them and support them unless we have customers who say that they work. That's like literally the line now is you go into ShipRoom and say, I'd like to ship this feature, and they go, okay, how many customers have used it? I'm pretty sure 2 or 3. Go prove to me that there's some more using it, and then we'll let you ship it and support it. Otherwise, it just lives in the Insider program until we get that. So let's take a quick look at a demo of some of this. And I got some cool stuff kind of mixed in here too. All right, so this is my laptop, my workstation. This is what I use most of the time. I'm going to switch over. I do all of my console in WSL, including all of my Docker for Windows stuff. So how many people use WSL? Few. How many people don't know what WSL is? All right, WSL is our Windows subsystem for Linux. It is our bash shell within Windows. So if I minimize this, I'm still running Windows here. I'm just running WSL, and I'm using it through a terminal emulator, which gives me nice things like Alt-Enter and Control+ and Control-. The link to this emulator is in my slides, and we've got it hooked up so it actually can run Docker against Windows. So I can do Docker images, and I'll actually see the images hooked up to the Docker engine on Windows. So the way this is actually working is it's using a relay. It's kicking over into out of the WSL environment and back over onto Windows through a name pipe emulator. And the directions for this are also in the slides as well. So why would I do this? One very simple reason, tab completion. I am a terrible speller, and so the ability to just be able to hit tab and get the images is super powerful for me. So I just listed out all the Docker images that I have on this machine. I've got quite a few. I will call out a couple things though. So I've got 1803, we just shipped that. All right, we can see that is 286 megs on disk. I've got the old Nano server image at 1.13 gigs. So this was the one that was shipped with Server 2016. I'm going to talk a little bit about server core versioning because this tricks people up a little bit. So here's server core tagged as latest. It is 10.5 gig. It has an ID of AB6 something or other. And then we also have it tagged as LTSC 2016 with the same tag. So the way that we versioned and tag our Windows images, we followed what we saw in open source. So the last long-term supported release is the latest. So even though we've shipped newer versions of Server 2016, they're part of the semi-annual channel. They're only supported for 18 months, so we did not tag those as latest. We tagged them as the version number that they are, 1709 or 1803 or SAC. So if you pulled Windows Server Core SAC, you'll get the latest semi-annual channel release of that, right? Now, we've gotten some feedback on this, both in the affirmative, like, yeah, that sounds good. We've gotten in the other direction, like, no, that doesn't make any sense. I don't have an opinion. I'll change whatever we do tomorrow. I need customers to tell me, yes, we like this better, no, we don't. We're fluid. It's just a couple line change for us in a script, and we can tag it with whatever we want. So let's go ahead and run a container on this machine. So I'm going to do docker run. We'll just do Microsoft, so I can get my nice tab completion, Nano server, 1803. We'll just do ipconfig, whatever we want. So what's actually happening right now, this is the first time I've run a container since I rebooted. It's going to run a Hyper-V isolated container. We always run Hyper-V isolation on Windows 10 because we want to ensure that we're running the exact same kernel, the exact same configuration as we're going to run in production. So my laptop's a Windows Insider. I'm part of the Insider flighting ring. I'm actually part of the special Microsoft Insider flighting ring, so I get the dog food before even you get the dog food. I'm running a different kernel. I'm running the current branch that we're under development for. I want to make sure that the stuff I work on works the same way locally as it's going to run in production. So we always use this Hyper-V isolation. So that first one takes an extra second or so to start up, but from now on, we're actually cloning the virtual machine that we're using for that, so we get much faster startup times, as we can see here. If you want to actually see some of this in action, let's open a regular command prompt. I can run hcs diag. This is a tool that we just added in the recent builds. I'm going to run this under here so I get a bigger screen. So one of the cool things you can do within WSL is you can run regular Windows apps. So I can run hcs diag, and I can run hcs diag list. Oh, I can run it as an admin. So I'm going to have to run it from command prompt, sorry. What hcs diag allows us to do is actually see what's happening under the covers. And so I can see that I've got this template created. That's the container template. And if I started a new container and I had it actually run long enough to stay alive, so we'll do rm-it Microsoft Nano Server 1803 CMD. So that's now running. If I do hcs diag list, we'll see that there's a template, and then there's actually a running container here as well. So why is it called hcs diag? It stands for Host Compute Service, because at Microsoft, everything is a three-letter acronym. We also have the host networking service, which does our networking components. So that's the underlying platform pieces to this. All right, so we've played around with containers a little bit. Let's actually get into a more realistic example. So I'm just going to switch over to another screen here, another desktop. So one of the guys on my team took an old version, old demo app we have called FiberCam Fabric. FiberCam Fabric is an ASP.NET web app. I think it's like 4.0, .NET 4.0, and has a SQL backend, right? Sound familiar? Probably have a few of those kicking around. So here is the FiberCam Fabric repo that he created. and there's 7 commits on it. So we can go look at the history. So he initially moved it over from Codeplex, because that's how old that thing was. He added our public use license, he added a README and a git ignore, and then we started into the interesting stuff. All right, so let's go look at this change that he made. So he added Dockerfile and compose. Let's just look at the file. So I'll ignore the solution file, but let's look at this Docker file. So here's the Docker file. So it says from ASP.NET, so he's using our Microsoft ASP.NET container image. There's this arg source thing that Visual Studio likes to use. It's setting the working directory as www-root, because that's where we're going to put stuff. Then it's changing the app pool model to the local system, and then it's just simply copying the source files out of the Visual Studio build, because that's where the source came from, that's the arg, to, or from obj docker publish to that source directory. So it's literally just copying the files into that container image. That's actually all that's happening. So what else did we change? Okay, so there's a web config change here. Interesting. So he went in and put in a hard-coded password. That's pretty secure. We'll have to think about that a little bit. Put that in 2 places. Okay, that's probably not going to work. And then he added a README file. And then he has this Docker compose file. So this compose file says, okay, it's a web, and that's the context to build it. And then there's this other compose file, and that says, okay, there's a web tier, and then there's this database tier. Oh, there's a health check. What's the health check do? Well, that actually allows us to check the health of the database every periodic interval. So we can see that it's interval 1 second, and it does 20 retries. And then it's on a NAT network. All right, so that's the initial thing he did. So I'm a little concerned about that password thing, but we'll get back to it. And then he's got a new commit here. So what did he do here? All right, so he changed 1 line of code. So we had to recompile, but okay, pretty small. He changed the version. So now he's using the semi-annual channel, 1709, and he's using the latest version, 4.71 of ASP.NET. Okay, I wonder why. So these are all config changes. That's not interesting. Let's just go back, look at a set of files in there. Sorry. There's all these project file updates. Okay, web config. So what he did in the web config here is he added in the configuration builder, added in that we're using the configuration builder again, and we got rid of the password. That's good. So what do we have now? Well, we've got this DB SA password and this DB service host in there now. And those are variables. Okay, where are those variables coming from? Well, if we go look at the Docker Compose override, we're now setting the passwords in the Docker Compose file. So we're still got a hard-coded password, which isn't great, but at least it's in a config file, which is a little better than actually having it as part of the container image. So we'll come back to this in a few minutes. Just keep in mind that we've got this password that's floating in this config file. But if I kick over to a machine I've got running in Azure, I've actually gone ahead and used Docker Compose to bring up an instance of this application. So here it is. This is Fabricam Fiber. So I can go in and I could like create a new ticket. I could interact with this site, do whatever I wanted to do. But what I really wanted to show you is we've got some pretty neat integration that we've built into VS Code now. Actually, that's probably why it was taking a second to run. So I can actually see that the database is down. So let's go ahead and just restart that container. And while that restarts, let's see what else we can do. So we can do things like show logs. We've got some images here. We could just directly from the image. Oh, can't restart. That's probably why. Inspect the image. So we can do something like an inspect. So let's actually inspect the database image. So this allows us to see all the metadata that's in the image now just directly out of VS Code. So that's pretty cool. We can still see that it's got this password being passed in. That's probably not desirable. So we'll have to figure out how to fix that. But we'll come back to this guy. We'll come back to our Fabricam Fiber in just a minute. But just kind of keep in mind, we've got it up and running as a dev box now. But we're going to want to go into production, and we're going to want to fix some of these things as we do that, right? So we'll go back over to our slides. So that kind of gets us out of desktop. So we've built something on our desktop. We built a container image. We put it into Docker Compose. We've done a little bit of connecting the dots. One of the things we might want to do later, though, is do some testing against it. Or maybe we've got some other stuff. So I'm really, really excited to be able to announce today for the first time that we're going to add another container image. We're going to add a Windows container image. So what is the Windows container image? It's Windows. Instead of server core, it's full Windows. So it's got the GDI binaries, it's got our DirectX binaries, it's got the full surface of Windows. It's huge. It's like, I think it's 13 gig on disk, something like that. But it provides all of that compatibility. Right. So why did we do it? Well, we had some internal teams asking for it. So we were like, okay, fine, we'll make you a container image, see what you can do with it. Then we had a couple customers start asking for it. Then we had more internal teams start asking for it. Then we started seeing internal teams doing interesting stuff with it and making it work. Not everything works today. Like, you can't remote desktop into it. It's still a headless server. It's still built for doing kind of headless server-y things. But you can do interesting things like run GDI rendering, or I actually talked to 2 customers this week who wanted just that. So this is our answer for them. I suspect with a little bit of work, we could probably get things like Selenium working in there. What we really want is we want to know what you want to run in it. We want to see what your experience is. And just like we did with Server Core, I'm sure we can make this thing smaller, we can make it faster, we can make it leaner, meaner, all of those things. But it's a really nice option for these additional pieces of workload. Right? Exciting? Yeah? Oh, and there's a nice little graphic. So Nano Server, Server Core, now Windows. All right, so let's talk a little bit more about container orchestration. So we went from our desktop. Now we're going to go into building something for production. So friends in marketing made this pretty slide for me, so I'm using it. So what are some of the elements of orchestration? What does orchestration mean? Orchestration is how we connect containers together. It's how we talk about the process of a web server talking to a database container and connecting them together. So it does scheduling. It knows about all the nodes. It knows how to put containers on the right nodes and schedule them. It knows about things like affinity or anti-affinity. So if I've got 3 web containers, I'm going to scale up my web tier. I probably don't want those to scale up on the same node. It's probably not going to do a whole lot for me, so I would set some anti-affinity there. Like, please don't put all the web tier on the same node. Thank you. Equally, I might have some affinity. I might say, I really need the web tier to be close to the database tier. Like, I would actually like those to be on the same node, so I have low latency, right? Or I've got some middle tier that I want there, right? It knows about that stuff. It knows about health monitoring. So we saw that health check in there. I can write as many health checks as I want. So for a web tier, I might say curl this every couple seconds and just make sure the website's up. If it's not, shoot the container, restart it, right? It knows about failover. It knows how to fail things over. If a node goes down, it knows how to bring the containers up somewhere else. It knows how to scale things that can be scaled. So as I write my configuration, I can say web tier can scale, right? Database tier, maybe not so much, right? It's got some state. I really can't scale that in the same way. I just need to make bigger containers for it. It knows how to do service discovery. It knows how to do upgrades, all of that kind of stuff. Kubernetes has really become the de facto container orchestrator, largely because of its portability. So it is available on every cloud. It's available on Google, on Amazon, on, of course, Azure. It is available on-prem. It is available in China. It's available everybody's got a Kubernetes service now. For me, the bigger thing is the ecosystem around it. It's so extensible. There's storage plugins from all the storage vendors. There's network plugins coming from all the network vendors. There's network integration from all the clouds. And then you get into the actual ecosystem of developers. You can go pull down a kube app starting configuration or a Helm chart that has Redis HA already working and tested and validated. So there's a huge ecosystem around that side as well. So we talk about it empowering to do more. So it knows how to do things like deploy your applications and quickly and predictably scale them. You can scale things on the fly. We'll actually see a demo of that in just a minute, of scaling up the number of instances. It makes rollouts super easy. So I can just go in and say, all right, I've got a new version of the web tier. Please roll that out. And when you do that, do it smartly. Like take down one container, bring up another one, make sure it worked, then trickle that through. You can do things like affinity and anti-affinity and hardware limits, all of those kind of things. So what we've been working pretty hard on is getting to a point where we've got mixed Windows and Linux clusters. So what this means is the Kubernetes control plane runs in Linux. There's no reason for us to port that over. We can run a Linux container, so we could run it inside of a Linux container if we wanted to. We'll just leave that in Linux. But then the actual worker nodes now become a hybrid of Windows and Linux nodes. Now, you could have all Windows nodes if you wanted to, and I would love that. But the reality, most people are going to have some Linux workloads and some Windows workloads, and so they have some Linux nodes and some Windows nodes, and they can schedule their work against each one. So what that's actually meant for our team is that we've had to go build Windows versions of what we call the kubelet, which is the kind of the agent that lives on the actual node, the kube proxy, which is another part of the agent, and then we've been working on a set of plugins for storage and networking. Ultimately, those plugins for us are reference designed so that other people will go replicate that and build specific network and storage plugins for the various implementations and places they would run, right? So I'm not going to go build the storage plugin for NetApp as much as they would probably love me to do that, but I'll give them a good start, and then they can go build the storage plugin for a NetApp filer, or Google or Amazon or anybody else who wants to build a plugin. So what's our roadmap with Kubernetes look like? Again, we got an eye chart. I'll bring it up a little bigger. So Kubernetes 1.5, which was December, was our alpha of Windows support, which meant if you could get it to work, you were special. It was possible. It just and it had a lot of limitations. You can only do one container per pod. A pod in Kubernetes is a way of having multiple containers kind of co-located together inside of one bigger container, effectively. So that was kind of interesting. Then we got to September. We added config map support. We got secrets working, so we can now do passwords and things like that. We had volumes working, but there was no volume plugins, so that was kind of half-baked. And we actually had a documentation. That was neat. Now, as we looked into Kubernetes 1.9, so this was last December, basically a Christmas release, the community declared us beta support. So the Kubernetes community said, all right, Windows is now in beta support, which is kind of a weird thing because it's a community project, so they support what they feel like supporting. It's on their own time, or our own time. But the important thing is what we actually brought in there. So we now had pod and node level stats. We had support for what they call kubeadmin, which is a way to administrate the whole Kubernetes cluster. We had a CNI plugin for OVS and OVN, the Open Virtual Switch and Open Virtual Networking. And then if you're running with Windows Server version 1709, we could now do multiple containers per pod. So we had a Linux equivalency of multiple containers per pod. We had kube proxy work with kernel mode, so it was actually fast. Before it was pretty slow. A lot of networking and a lot of general improvements in performance, startup time improvements, pull improvements, just a bunch of across-the-board optimizations. And we had a CNI plugin for networking. And now, as of March, with 1.10, we now have pods working with Hyper-V isolation. So we can now Hyper-V isolate our pods. So what we actually do is that VM, that utility VM that we spin up to run the containers inside, that's the pod boundary. And then we can run multiple containers within inside of it. So if I've got something like a Redis cache and a web server, I may want to locate those in the same pod as the kind of a tier 1 of caching. Now I can put those side by side. They're guaranteed to be in the same pod. Super fast networking. I'm not going to do any egress out of that pod. We've got CPU memory reservations, and we've got it as a native Windows service now, so we don't have to run it as a command line option. So kind of directionally, the way we're headed in this, we've got Server 2019 coming out this fall. We're working really hard within the Kubernetes community to try to get that to be the point when Kubernetes can say, all right, this is ready for Windows. So we can align around that time frame. So let's go take a look at Kubernetes in action. So remember, we've got Fabricam. We were using Fabricam for a bunch of stuff. And when I do this, I'm going to actually show this in OpenShift. So we made an announcement earlier this week with Red Hat that we're bringing OpenShift not only support for Windows, so we can run, so OpenShift will be able to support Windows and Linux nodes. We're also making OpenShift available as a managed service in Azure. So this will be a premium container orchestration experience for customers. And one of the things, and part of the reason I decided to do this demo this way, the UI is it's so nice. So we've got Fabricam Fiber, and in that same GitHub repo, we've gone ahead and made it a Kubernetes project. So we've changed it from Compose over to Kubernetes, and we actually published it into this catalog. So now if I'm an IT admin or maybe I need to deploy a new instance, all I have to do is go in here and say, all right, I'm going to deploy FiberCam Fabric. I'm going to pick the project I want to use. So I created one earlier called Taylor Demo, and I'm going to hit Create. And so what's actually happened is we're now spinning up an instance of FiberCam Fabric. Just that easy. No one had to do anything. It's all parameterized and taken care of. And we can see that we've already got one DB pod that's up and running, and we actually now have one web pod up and running. So we can go dig into these a little bit, take a look at what's there. So in this case, we actually used SQL Server running Linux. So that's actually deployed to a Linux node. And we've got, of course, our web tier, which is running FiberCam Fabric Web 1709.471. So that's deployed to a Windows node. So we actually have a hybrid application. We only chose to use the SQL Linux so that we could show that we had a hybrid application. But yay. And we can do stuff like scale up and down our pods, which we'll do in just a second. We also have this routed out to an external load balancer. So it's using XPIO as the router. So we've gone ahead and started that up. Now, first time this starts, it uses Entity Framework, so it's going to go spin the database up. So that's going to take a second. While it does, let's take a look at the configuration of the database tier. So remember we talked a little bit about, like, boy, this thing is using these secrets, and that's kind of weird. What we've now been able to do is we've got SA password, but it's now a secret. So it's now being managed by Kubernetes as a secret. And so it's provisioning that secret at the provisioning time, especially for that application, and passing it into the SQL container image and the web container image. So if I spun up another one of them, they'd have a different password, right? And it's managed all automatically for me. I don't have to do anything at all. All right, so that's kind of cool. So this guy's going to time out the first time, so we'll just start him up. And while he's finishing that, I'm going to go over to the pod section here. So this is the database pod. So that's the instance of the database that's running. So I can go in and I can look at the environment there, or I can look at the logs. So this is all the logs that got spit out. So we can see it started FiberCam Fabric, it started up the database, did a bunch of other little things. So I could always go look at those logs if I wanted to. Right from here, I can also go into the terminal, so I could interact with that if I needed to. And so we've got FiberCam Fabric up and running. We can create tickets, we could do all that stuff, but what I actually want to do, I know this is going to be a pretty popular service. FiberCam Fabric's a little bit sketchy, so we're probably going to have a lot of support tickets. I'm going to probably need some more web tiers, so I'm just going to go ahead and scale that up to 3. So we now see that it's scaling itself up to 3 automatically. So while I do that, I can go in, like, create a ticket and look at another ticket. I can do all of the things I would expect to be able to do while we're scaling up the number of pods. So in just a second here, we'd see that go from 1 to 2 to 3. And we could scale it up as many times as we wanted to. If we killed one of the pods, it's going to automatically restart it. So it's now up to 3. If we went over to our pod overview here, come on. Oh. So if we go to our pods, so there's one of the web tiers. If I go to that guy and I say delete, we already see immediately it's already recreating the pod because I told it I wanted 3 of them. Once one of them went away, it started up another one. If I wanted to scale down that application, right, it's things are going a little better. We don't need as many of them as I thought. I can just simply go back to the deployment and go to the web tier, and I can scale it back down wherever it went. I've lost it. There it is. So I can just simply scale that back down, and it'll scale it back down to 2. If I needed to rev the version, I could deploy a new version in, and it would automatically roll that out for me, right? Super easy, really a nice experience. And this is what you'll be expecting to see coming into this fall, is more of these experiences. There'll be a number of different container orchestrators from Kubernetes. We'll have, with OpenShift now, we'll have that. We talked to Docker earlier. Docker said, hey, we've got Docker EE coming with Kubernetes. That'll be another choice for you. We announced AKS support is in private preview sign up this week, so that'll be an option for you. You can only expect to see more and more of them. So a couple of the other things that we're working on pretty heavily right now, building out the networking ecosystem. So we talked a little bit about OVS, OVN. We're also working with Project Calico and Flannel and Tigera, the backers of Calico, to enable more networking options. So this will allow us to do pretty nice security operations, do really nice overlays, encrypted networks, all of those kind of things. So what we have today in production, we have OVS, OVN ready to go. We have our first party WinCNI for static route configuration. And then experimental with Flannel and an overlay. And then very soon we'll have dynamic routing with BGP and Calico coming. So these are all open source projects. You can go look at them, play with them, kick the tires, give feedback. They're ready to go. And then we also now have open source storage plugins. So about a week and a half ago, we opened up our GitHub repo with 2 different storage plugins for Kubernetes, one for iSCSI and one for SMB. So if we think about that SQL database, now I could actually put all of the data on a persistent database or a persistent volume so that if I needed to rev the database, it would be persisted, and I would just restart with a new version of the container image. All the data would be persisted out, right? And we feel like between iSCSI and SMB as a starting point, that covers a lot of our bases for container images. So if you're interested in playing with OpenShift, we have a developer preview program set up for that as well. Again, these links are all in the slides. So you can go and get on the Google form for that. We have an email alias with members of Red Hat and Microsoft on it. And then, of course, all of it's open source. So if you're interested in this stuff, join the Windows SIG calls. We have a call every week, or just sign up for the distribution list. Patrick, who works on my team, is a co-chair of the Windows SIG now. So we're getting really involved in that work. So I do want to talk a little bit more about some of the other orchestration options as well. So we went through the elements of orchestration. There's a lot of different options here, and one of which is Service Fabric. So Service Fabric is our microservice platform, but it has a lot of the capabilities of an orchestrator. So it knows how to do things like scale up and scale down. It knows how to do lifecycle management, health checks, a lot of those kind of things. And it has the basics for container orchestration as well. So you may be in a world where you've got a whole bunch of reliable .NET services. Maybe you're already using Service Fabric today. Actually, how many people, is anybody using Service Fabric? How many people? All right. Got the Service Fabric guy with the shirt. So, we have a number of customers who are really excited about reliable collections and some of the actor models that Service Fabric provides. You can bolt that in with a Windows container right alongside of it. So now if you're on a modernization journey, maybe you've got some old .NET apps that you're going to move forward, you can bring those over as containers and start bringing in Service Fabric pieces along the side. And Service Fabric, little alone, runs on Azure as well as on-prem as well as third-party clouds. It's an open source project now. You can go review it, contribute to it, whatever you want to do. And it really is what powers our business. Like, Azure does not run without Service Fabric. It is what powers SQL. It is what powers Cortana. It's what powers a number of our services under the covers. So a couple of key scenarios around it: lift and shift, mission critical applications, IoT processing, new cloud apps. So it is a pretty interesting option, something you should definitely look at and consider. Another option, Pivotal. So why do I have a Pivotal slide here? So Pivotal actually worked really hard with us and on their own to move their platform as a service offering on top of Windows containers. So with the latest release, they're using Windows containers under the covers transparently. And this is just one slide out of it. It's actually a pretty neat operation. So what they've done, they've got this Diego auctioneer that pushes things out to nodes. Under the covers, they wrote, in open source, it's called WinC, they wrote an abstraction to our container APIs, built on our open source library, and then they've built their service on top of that. So they had their own containers before. We gave them a new platform option. They just built on top of it. So I was pretty excited to see that. It was kind of a good recognition that we had built something pretty interesting that a lot of people were going to build on top of. And the last thing I'll kind of go over, I just want to touch for a minute or so on some of the Azure services. There's a bunch that I really wanted to demo and talk about, and we just didn't have time to go through all of them. In particular, I want to talk a little bit about Azure Container Registries and Azure Container Build. So we showed, I kind of built the container image locally. Well, where would I have put that? I could have put it on Docker Hub, but for a lot of our enterprise customers, that's not where they want to put them. They're going to want to put them into a secure container repository. So the Azure Container Registry provides that. It's geo-replicated. It's private. You can put all your container images in there. We've had a number of sessions on it throughout the week, so if you hadn't heard about it or you're curious about it, Steve Lasker, a good friend of mine, he did a lot of the work around that. Rohit, who's on his team, I saw walk in the back a few minutes ago, so you can mob him. One of the cool things that they just added in the last week is Azure Container Builds. So what this allows you to do is hook that up to a trigger. So every time a change happens, like a Git submission happens, or in the case of our team, we actually use a Slack bot to trigger. Soon it'll be a Teams bot, so no one get mad at me. To trigger container builds. So you just tag the bot, it kicks off a new build. Today that's Linux only. They're going to have Windows support very soon for it as well. So that'll allow you to automatically do container builds, and then they just get published directly into your container registry, and they get picked up by the orchestrator, and they can get pushed out automatically if that's what you want to configure. We also have Azure Container Service. We mentioned that. That's now open for private preview sign up. So if that's something you're interested in, please sign up for it. The more people who sign up for it, the faster they work on it, the faster it goes to production. We have Azure Container Instances. Those are GA for Windows and Linux now. Pretty neat piece of technology. Of course, virtual machines, so you can run whatever you want inside of it. And then there's a whole bunch of partner solutions. We talked about OpenShift and Pivotal and Docker. We also continue to work on Mesosphere. So if you go look at the Mesosphere repos, there's a consistent stream of Windows support coming into Mesosphere. It's just been continual over the last 2.5 years. And we actually have a few very large customers that are built on Mesosphere running Windows containers under the covers. So that's another option just to consider. So I do want to say, if you've enjoyed this session, please fill out an eval, give us a good thumbs up. That helps us have more of these kind of sessions in the future. If you didn't like it, give Mark Rusinovich a thumbs down instead. And a couple resources to go look at. Our main doc page, aka MS Containers. If you have questions, concerns, feedback, thoughts, file a GitHub issue. If you go to that link, there's an edit button on the right side. That'll get you into our GitHub repo. That is the best place to file feedback issues. That's where we spend more of our time now. We also have a guide for nested virtualization. That is pretty powerful if you're going to use Windows 10 on Azure. And then, of course, a number of different blogs. And with that, we have just enough time for questions. Yeah.
Just really simple. Would you put the first slide up with the link to the slide?
Yes, I will put the first slide up with a link on it. All right, this is not going to work. Boom, there you go. All right. Yep. Fabricam, yep. So the question was, for the Fabricam app, was upgrading to .NET 4.7 required for it to be containerized? No. The reason we did that is so that we could get the configuration service. So that was a new feature that was in .NET 4.7. So that allowed us to parameterize the web config and pull that from the code. You can use environment variables in previous versions. It was the ability to use the configuration builder object in the web config. So that was kind of an optimization. Even all the way back to, we have a customer running .NET 2.0 apps. They literally moved it without any change from 2003 over that had environment variables being pushed in, and that worked just fine. It's just easier to parameterize that way. So the question was, do the previous images support that? So the .NET 3.5 image will, just like .NET 3.5 has support for 2.0.
So there's a .NET 3.5 image?
Yes, there's a, yeah. Yeah, the .NET team publishes .NET 3.5, .NET 4.x, 4.6, 4.7, and 4.8, as well as .NET Core. The .NET Core images are all based on Nano Server. So if you wanted those for a different version, if you wanted them on Server Core or the new Windows image, for example, you could just use their same Docker file and build them against those. They just publish the Nano version of them. Yeah.
So we were trying to get, for our build environment developer machines, use Docker containers to host SQL Server, multiple instances, and we have a requirement to use Windows authentication.
Yeah.
So, and then these databases also use distributed transaction coordinator like servers.
Yep.
We ran into all kinds of problems. This is hosting on like Windows Server 2016.
Yep.
So I don't know if it's the managed group service accounts are going to solve that, if we need to update our servers.
Yeah. So for the recording, the question was around multiple SQL instances on the same server with DTC as coordinating between them and Windows Auth.
Yes.
So we had an issue with group managed service accounts. If you're trying to use the same group managed service account on the same node for two different instances, that was causing some challenges. That's fixed or being fixed right now. I was reviewing code changes that were going in last week. So that was one of the things that we worked on for Server 2019. So expect to see even better group managed service account support. That was feedback we got from customers. DTC is a whole different challenge for us. We're trying to see how far we can get with DTC. It's a pretty old component, and so a lot of the original team that worked on it is no longer around, and it's very much in sustain mode. It's on our roadmap to keep working on. I can't make any promises about it yet. A lot of it's your mileage will vary. Some people it's working well enough for them. Some people are still pretty challenged with it. I would say give it a try. Let us know how it is or isn't working for you or what errors you're seeing. And we'll see if we can work around them.
So platform requirement then, can we get away with using Windows 10, 1803, and Server 2016?
So on the platforms, you can use Windows 10 and you can run server containers on top of it, and we'll use Hyper-V isolation. Now the group managed service account stuff is in the actual OS, so you need to be running the latest version of Windows in order to get that part working. It's one of those nasty ones that kind of spans that boundary.
Yeah, you've got a full fat Windows container, and you mentioned DirectX. Any chance of a driver through to a GPU from a container? Please.
Did I lose my mic? Yeah. So we are working on, we're really thinking about GPUs right now. We have parts of it working. It's a roadmap item. We got to figure out exactly how far we can get. Is it more for like ML-based workloads? Is that what you're?
No, it's for rendering, and then we're going to encode that to video and stream it to a browser, so you can do the high-performance CAD rendering in our case.
Okay, so like DirectX kind of optimization, that kind of stuff.
For sure, yeah.
Yep. Yeah, you're not the only customer that we have looking for that, so it is definitely something we're looking on. We may get it for 2019. If we have it working, we'll get it supported. If not, it'll be the next release.
When is this Windows container available?
Windows containers have been available since Server 2016 GA'd.
No, the full-blown.
The actual Windows one.
Yeah.
We'll be putting it through the Insider channel probably next week, if not the week after.
Okay, it's inside the channel.
We're just waiting on the final license terms to go into it. And then it'll be available in the Windows Insider channel. Yeah.
You have the managed service account.
Yep. Yep, so we're adding group managed service accounts to Kube. We're working on that through the SIG right now. So actually, it's an area, if you've got feedback or requirements around it, if you jump on the Windows SIG, I think it was 2 weeks ago they talked about it. Yep. Yeah, so it's being worked, so it's got to go through the way that Kubernetes works. All features start out in the SIG, and they start out in their local SIG. For us, that would be the Windows SIG. Once the Windows SIG votes and says like, all right, we're good, then it usually goes to another SIG. In this case, it would go to the node SIG. The node SIG has to look at it and say, okay, we also agree with the design, like this is all good, it's not going to break anything in Kubernetes. And they may even defer it off to another SIG to go review it, which is actually the case with group managed service account, they went over to the secrets SIG and said, okay, let's make sure we don't intersect with their roadmap. Once it goes through all those, then we get the approval to actually start working on the code. And so we're in that kind of SIG review, final SIG review process now, and then we can actually implement the functionality and feature for it. We view that as a requirement for GA, though. We don't see, we got the feedback loud and clear a couple years ago that containers without SQL or without Active Directory support was not really a viable answer. I stood on stage and said, no, we're never going to do it, and like half the room walked out. And that was kind of a key indication. So that's where the group managed service account work came in. All right. So we're a little over time. Thank you all for staying. Thanks for all of the support. If you have other questions, feel free to let me know. Drop by our booth. I think the expo is still open. We're hanging out over at the Windows Containers and Microservice booth, so over with the Azure Container team. And yeah, thanks. Have a great rest of the day.